All right, this is Mr. Gillum, and today we're going to work on some expressions. And one of the things that I really want you to know is that the difference between an expression and an equation is that there's no equal sign. So when I compare an expression with an equation, expression, no equal sign. Equation, equal sign. Okay, so an expression has no equal sign, an equation does have an equal sign, and that's what's going to be the difference here. We're going to practice expressions for a while, and then we're going to start adding equations in the mix. We're going to start having equal signs. So we're not finding what anything's equal to. All we're doing today is we're combining like terms, just simplifying. Okay, so I shouldn't see any equal signs anywhere today because we're not doing equations, we're doing expressions. So let's take a look here. I have an expression over here, and this is the expression. It's an algebraic expression. Okay, and there's some things we need to know about it. Okay, it's a combination of variables, operations, and numbers. Okay, you might see addition, subtraction, division, multiplication, anything. Okay, can be an expression using those four main operations. Each term is separated by an addition or subtraction sign. Now that's really, really important because sometimes it's hard to tell how many terms there are if you're not sure about something like that. So in this case, each thing, so I see an addition sign, a subtraction sign, and an addition sign. So on either side of the addition sign is a term. So in this case, I have 1, 2, 3, 4 terms. So in this case, I have 4 terms. All right. There's 4 terms because there's 3 addition or subtraction signs separating the 4 terms. Okay. All right, so there's 4 terms here, each one separated by addition or subtraction sign. That's really, really important. Okay, a constant is a term without a variable. So looking up here, I have the first term has a variable, the second term has a variable, the third term does not have, or has a variable, the fourth term does not have a variable. So in this case, the constant would be 10. Okay, the number 10. Okay, a coefficient is just the number in front of a variable. So in this case, there we got several different coefficients. In this term, we have a coefficient of 2. In this, we have a coefficient of 3. This guy, we have a coefficient of, well, I shouldn't really, of -4. The sign in front of the number stays with the number. Okay, so we have 3 different coefficients. We have 2, 3, or -4. All right, it's going to be important. And finally, another important vocab term is like terms. Now, terms that are like terms are terms with the same exact variable parts and exponents. So this is really, really, really important. So for instance, it's going to be very tempting for me to write 2x plus 3y is 5xy. But that's not the case. If I have 2 apples and 3 oranges, I don't have 5 apple oranges. I have 2 apples and 3 oranges. They're separate. They're different things. These are x variables. These are y variables. I can't squeeze them together and make apple oranges. Okay. So like terms have the exact same variable part and the exact same exponent. So in this case, the only like terms that we have here will be the 2x and the -4x. Those are the two that can go together. Okay. So in this case, the -2x and the 4x are the like terms. 3y and 10 are different. I mean, they're all different things. They have to have the exact same variable parts. You can't add the 3y with the 10 because the 10 doesn't have a y on it. So let's not make it more confusing than it has to be. The variables and their exponents have to be exactly the same in order to combine them together. So let's take a look here. I have this expression over here again. This is the guy I'm looking at. And what we're going to do is just going to simplify it. Okay. And it's combining like terms and reducing all fractions. So have to have the same variables. You can't put an x with an xy. All right. Those are 2 different things. Have to have the same exact variable parts. The variables must be raised to the same power. Okay, we talked about that. Numbers by themselves are always added together. So if I saw 2 numbers like a 3 and a 10, I could put those 2 numbers together. All the constants can be put together. When I'm looking for the like terms, make sure when you circle the term that you're looking at that's a like term, you circle the sign in front of it as well, because that sign sticks with that term. Okay. And now this is going to be a real test of whether or not you are able to add and subtract integers. Okay, so you need to know your rules for same signs add and keep, different signs subtract. Keep the sign of the bigger number, then you'll be exact. You need to know that. That is important today. And that's why the sign in front of the number is going to matter. Okay, so all our terms need to be labeled with the proper and appropriate sign in front of it. So if I look at this equation over here, let's just pretend I was going to simplify this first example here. What I see is I see a negative 2x and a negative 4x. Okay, so I wrote those right here, negative 2x, and I'm going to put plus a negative 4x. Okay, I'm going to rewrite this in order from with my like terms together. Okay, let's look at more of it that they had the same. I see that this is a positive 3y and a negative 9y, so I have another 3y, and I also have a 9y, negative 9y. And then finally I have this 2x squared back here, and he doesn't have any like terms. He's all by himself. He can't go with the x's because he's got an exponent on him. So I'm going to put plus 2x squared at the end. Okay. Now what I've done here is I've already kind of done the change. I guess I should mention that. The change already kind of happened because when I wanted to put this negative 2, I put it negative 2x, and then also and a negative 4x. Also, and I had a 3y, positive 3y, and a negative 9y, and plus 2x squared. So I already did the change for you. I could also write it as negative 2x minus 4x plus 3y minus 9y plus 2x squared. But as you can see, once I do my change, it's the same exact thing either way. All right, so hopefully you caught that, but I prefer just to leave it the first way. Okay, so now that I have my my terms together, I can combine them together. Negative 2x plus negative 4x, same signs, add and keep. So negative 6x. And I also have these like terms, positive 3y and negative 9y. Different signs, subtract. 3 plus negative 9 is really just different signs, subtract. So 9 minus 3 is 6. And in this case, keep the sign of the bigger number. So 9 was negative, we're going to keep it negative 6y. And then finally, just my 2x squared at the end. All right. So same signs, add and keep. Different signs, subtract. 9 minus 3 was 6. The sign of the bigger number was negative. So we need negative 6y plus 2x squared. Now this is almost perfect. This is almost a perfect answer, except for there's one last thing I need to do. What I need to do is I need to write it in alphabetical order with the biggest exponents first. So x comes before y in the alphabet, so I need to put one of these first. In this case, I'm going to put the 2x squared first because it has a bigger exponent on it. Minus 6x comes next, and then minus 6y. He comes last because he's last in the alphabet. Life's not fair, little y. Okay, so there's your first example. We're going to do several of these because that might have been a little confusing. Let's take a look at another one here. In this case, I want you to circle basically what the like terms are. I see an x squared here and an x squared in here, and those are the exact same variables, the exact same exponents. I'm going to circle that. I'm going to make sure I circle the sign with it as well. Okay, so that negative 3 stays with the x squared. I'm going to go ahead and write those down. 3x squared from him, and then a negative 3x squared right there. Okay, this time I chose not to change. All right, not yet. I also see a positive 6y and a positive 7y. Those are like terms. They have the exact same variable and exponents. So I'm going to write those down next. Plus 6y plus 7y. Now that I have my terms all in order of where I can add them together, I'm going to go ahead and do that. I see that these two can go together. I know that 3 minus 3 is 0, so 0x squared. Or I could say 3 plus negative 3 is still 0, so 0x squared. And also I want to put together these guys over here. Positive 6y and positive 7y makes positive 13y. This is almost perfect, except for I don't need to write 0x squared. 0 times anything is still 0, and 0 plus 13y is still 13y. So my actual answer is just going to be one term, 13y. Now, I want you to be careful because a lot of times I see students try to make their answer look like their simplified expression look like just one term, okay? But a lot of times there's going to be more than one term, so we need to make sure that as the case when it needs to be. Once again, let's look at these. I'm going to identify the like terms. I see two x terms that could be put together, and I also see some y terms that can be put together. All right, so now I'm just going to write this out in order. I'm going to say my 3x, and then my minus 2x, and then I have a positive 2y, and a positive 5y. And now I put them together where they can be combined together. 3 minus 2 is 1x, and then 2y plus 5y is 7y. Now I wouldn't write 1x, I would just write x plus 7y, and that would be my answer. Now, do not try to squeeze those together. That cannot be 8xy, okay? 8xy is a no-no, okay? You can't combine x's with y's. They're separate things, okay? It's going to be hard to remember. I see a lot of mistakes on that. Once again, now we got a few more exponents involved. Let's take a look here. Now, gotta be careful. I see an a squared here, and I see an a squared here, and I'm going to make sure I circle that sign right in front of him as well. So let's go ahead and write down those first. And then let's take a look at the b's. Now, it's going to be tempting to put this b squared with this b, but to be like terms, they have to have the same variable and the same exponent. So this guy is separate from this guy. All right, so I'm just going to write negative 3b squared plus 4b. I'm not able to combine those together because they're not the exact same variable with the exact same exponent. All right, so let's take a look here. I do know that these can go together because they have the same exact variable and exponent. So 4 plus 10, 14, a squared. Now, unfortunately, I can't squeeze this with this, so I need to leave them as two separate parts. And now it's just a matter of putting my terms in order of alphabetical order. I have my A, my B's, and my B's again, and this B has a bigger exponent than this B, so it's actually already in the order I need it to be in. And we're going to call that a trinomial because there's 3 terms there, but we're going to learn about that later. For right now, really the emphasis is just on making sure we can combine our like terms. And so finally, let's do this last problem here. I see negative 3x, a positive 5x, and another positive 5x. All 3 of those are like terms. Let's write those down first. And then I have this negative 2y, which doesn't have any like terms, so I can't be squeezing that in anywhere. Negative 3 plus 5 is 2x plus 5x minus 2y, and 2x plus 5x is 7x. Oops. Minus 2y. So now I just need to make sure my variables are in order from alphabetical order, and they are. X comes before y in the alphabet, so my answer is 7x minus 2y. Please do not change this to 5xy. Okay, that is not correct. Those are different things. These are apples, these are oranges. I can't take oranges away from apples and get apple oranges. It doesn't happen. It doesn't work that way. So that's it for today. Combining like terms, and like I said, I want to emphasize again, these are expressions, not equations. Okay, expressions. There's no equal signs. I shouldn't see any equal signs on your paper today. All right, and that's it.